Hi, this is Mr. Anderson, and I get a lot of emails from students around the country, and they want me to give them a shout out, and so I'm going to give them shout outs now at the bottom of this video. But the students in my third period AP Biology class complained a little bit about that. They wanted to know why I didn't give it shout outs to them. So what I thought I would do is give them a video shout out. So if you would, period 3, let's see it. Thought. Okay, this is Mr. Anderson, and today I'm going to be drawing out the central dogma. Since it's hard for me to actually look at the camera and draw, I'm going to shrink my head and get that out of the way. Now, first of all, what is the central dogma? The central dogma is a term that was coined by Francis Crick. And so after they discovered the structure of DNA, and the DNA, if we draw out what it looks like, DNA looks like this. It's a double helix, and so this would be a helix on one side, then I have another helix that kind of wraps around that and looks like this. So once they figured out the structure of DNA, the next job was to figure out, okay, well, how do we actually take DNA and then make something out of it? And so how do we go from DNA to, let's use red for RNA, to messenger RNA? And then how do we go from messenger RNA eventually to, let me put U way down here. So how do we actually go to U? So how do we get from DNA to messenger RNA and eventually to U? So what I'm going to try to sketch out is how that process actually works. And so let's first of all start on the left side with DNA to messenger RNA. So first of all, what does messenger RNA look like? Messenger RNA looks like this. If we were to sketch out what it looks like, it's linear, and so it's just one line. On one side we have what's called the 5' cap, and that's kind of like a head on this side that identifies this as messenger RNA. On the other side we have what's called the poly A tail, so that's a bunch of adenines in a row. And so what the cap and the tail do is they actually protect the messenger RNA. And so how do we go from DNA to RNA? There is a protein called RNA polymerase, and what it'll do is it'll cruise down one side of the DNA and it'll read off the letters and then put them into messenger RNA. And so on my sketch here, to kind of keep track of everything, what I'm going to do is I'm going to draw a line all the way across, and on top of that line this is going to be inside the nucleus, and then on the bottom of this is going to be in the cytoplasm. And so the first thing, anything above this is going to take place in the nucleus. And so let's go back to a color that is DNA. So DNA, if we get even more specific into what DNA looks like, it's going to have a backbone that looks kind of like this. It's going to have a side to it. And so this is going to be what's called the 3' end, and then on the other side we have what's called the 5' end. And then they have letters on the inside, and those letters are what are called nucleotides. And so let's sketch out what those letters might look like. So this would be 1, this would be another letter, and then let me put some letters that go with this. And so this would be the letter A, so this stands for adenine. This would be cysteine. This would be another cysteine, this would be another adenine, this would be a guanine, and then this on this side would be a thymine. So there are 4 different types of letters, but they're organized in specific ways. And so you'll notice on here that some of these actually protrude a little bit more into the middle. Adenine is actually appearing, so that means it's a double ring structure, so it scoots out a little bit more, and it'll always match with thymine. So you can almost imagine in your head the other side of the DNA and how the thymine would hydrogen bond perfectly to the adenine, and the guanine is going to fit perfectly with the cytosine. And so if we were copying DNA, the DNA simply splits in the middle, and DNA polymerase is going to add the complementary side. But that's not what we're doing. What we're trying to do is show how we can go to RNA from that. So let me draw the RNA. So RNA is going to look like this. It also has a backbone, but it's just linear. And so opposing the adenine, we're going to have a uracil. And opposing the thymine, we're going to have a guanine. Opposing the other cytosine, we're going to have another guanine. On the other side of the adenine, we're going to have a uracil. On the other side of the guanine, we'll have a cytosine, and then on the other side of the thymine, we're going to have an adenine. And so the information that was up here is now information that is in the messenger RNA, and that can eventually leave the nucleus and enter into the cytoplasm. And so what does that actually look like? Let me choose another color. If we were to go out here into the cytoplasm, so on the big scale, if something totally microscopic can be the big scale, we've got our messenger RNA that looks like that. And let me try to do that in the right color. It's going to have a cap on it. It's going to have a poly A tail on that side. So this will actually scoot out through the pores in the nucleus. And the first thing that's going to grab a hold is going to be the bottom of a ribosome. We then attach a transfer RNA, and the first thing that will attach to that is always a methionine. And then we have other transfer RNAs that will just keep coming in, and each of those are going to bring a different amino acid. And so eventually what you get is a string of amino acids, and each of those amino acids will eventually become part of a protein. So the other part I'm missing on here is the ribosome. So this would be the ribosome here. This would be the messenger RNA, and then these are going to be the transfer RNAs that pull each of their amino acids to the middle. And so this is how it takes place in the cytoplasm. If we were to go over here and use kind of our code again, to amino acids we'll say is black, amino acids are going to look like this. So this would be one amino acid. These three letters in messenger RNA are what are called a codon, and those are going to code for a specific amino acid. In this case, UGG, and you'd have to use a chart to figure this out, is going to code for tryptophan. And the next three letters, UCA, is going to code for a different amino acid, and in this case, that's going to code for serine. And so the process by which we go from DNA to messenger RNA, that process is called transcription. What we're really doing is we are scripting, or we're writing out the message in the DNA in messenger RNA. This next process is called translation. Translation is when we take the messenger RNA and actually make a protein out of it. Now, is this a protein right here? No. This is simply a polypeptide. It's a bunch of amino acids attached together. That protein will eventually fold into a specific shape with alpha helices and beta pleated sheets, and it'll have a three-dimensional shape that gives it a specific structure. And so if we were to draw out what a human looks like, let me try to do my best at this. And let's give this guy some glasses. That, and maybe we'll give him a chin and a nose and a mouth like that. So when we have a guy like this who has, for example, red hair, the color of that red hair is a protein, and the protein was created by the DNA making messenger RNA and eventually making a protein. In this case, it's for red hair, or maybe it's for freckles, or maybe it's for blue eyes. And each of those is a protein, and that protein's message was in the messenger RNA. Before that, it was in the DNA. And so this whole process is called the central dogma. It's how we go from a message in the DNA to a message in the messenger RNA, and eventually we go to you. And so I hope that's helpful.